Question 7. Use De Moivre's theorem to determine the constants a, b, and c such that sine to the power 4 theta is equal to a cos 4 theta plus b cos 2 theta plus c. So let's do that. If we let z equal cos theta plus I sine theta, then you know that cos minus what? Sorry, z minus 1 over z is equal to 2I sine theta. And so here we want sine to the power 4, so it's z minus 1 over z to the power 4, which is going to be 2I sine theta to the power 4, which is 16, and I to the power 4 is 1, so 16 sine to the power 4 theta. And if I expand this brackets using binomial expansion, I'm going to get z to the 4 minus 4z squared plus 6, and it's just z to the 0, so it's plus 6, minus 4 over z squared plus 1 over z to the 4. And if we collect z to the 4 and the plus 1 over z to the 4, and if I factorize minus 4 out, then I'm going to have z squared plus 1 over z squared, and then the plus 6, and z to the 4 plus 1 over z to the 4 by De Moivre's again is 2 cos 4 theta and minus 4, and then this is 2 cos 2 theta plus 6, and we know that this is equal to 16 sine to the 4 theta. Now we're going to divide everything by 16, and if we divide everything by 16 we get 1/8 cos 4 theta minus a quarter, no, minus a half, I forgot the 2 inside, so minus a half cos 2 theta plus 3 over 8, and that's equal to sine to the power 4 theta. So we can say that A is 1/8, B is minus a half, and C is 3 over 8. Okay, the function f is defined by that thing. Okay, so it looks, right, first glance when you see that, it looks ugly. But let's just look at what the question's actually asking us. It's asking us to differentiate this function. Okay, so let's have a go. Right. It is 6 marks, so it's going to be something that's going to take a while. So, really do, it's the last question. You expect it to be difficult, but have a look. So if we kind of highlight each point, you can see that it's sine of 4 sine inverse of x over x to the power 1/5, and then minus 8 sine of 2 sine inverse of x to the power 1/5 plus 12 sine inverse of x to the power 1/5. So each one has got a x to the power 1/5. So the first thing I would probably do is say let t equal x to the power 1/5. And the question's asking us to differentiate. So I'm looking at this as a function inside a function inside another function. So this is like a triple or a double chain rule, so to speak. So now my function in terms of t is going to be sine of 4 sine inverse of t minus 8 sine inverse 2 sine inverse of t plus 12 sine inverse of t. And automatically this looks a little bit nicer than what it used to. Now again here we can see that there's a sine inverse t everywhere. So maybe I'll replace that. So let u equal sine inverse of t. So f of u is going to be sine for u minus 8 sine 2u plus 12u. Okay, well, I'm asked to differentiate. So when I differentiate this, I'm going to slightly switch notations. I'm going to get df du, and that's going to give me 4 cos 4u minus 16 cos 2u plus 12. But that's df du. Okay, remember I want df dx. So I could say that df dx is equal to df du times by du dx. But I don't have a du dx. Right? What I can get is a du dt. So this is what I mean by a double or a triple chain or whatever. So the du dx is now going to become a du dt times by a dt dx. Okay, so let's find du dt. Well, u is equal to arc sine of t, and the derivative of arc sine of t is 1 over square root of 1 minus t squared. That's in the formula book. So now I have my du dt. I need my dt dx. Well, I can get that too. I know that x is equal to x to the power half. So dt dx is 1/5 x to the power minus 4/5. And so what I have to do, I have to put all the get rid of all the t's and the u's and put all the x's back in, but I also have to times all my derivatives together. So when I do that, I'm going to get 4 cos 4u minus 16 cos 2u plus 12. That's my df du, times by 1 over the square root of 1 minus t squared. That's my du dt, times by 1/5 x to the minus 4/5. And that's my dt dx. And now I've got to clean this up. Okay? From part A, if you go back to part A, you knew this bit here. You knew that 2 cos 4 theta minus 8 cos 2 theta plus 6 was equal to 16 sine to the 4 theta. Well, here, I've got 4 cos 4u minus 16 cos 2u plus 12. So I've got double what I had before. So actually, what I can say is that this bracket, this first bracket over here, that I can replace with 32 sine to the power 4 of u. Times by 1 over square root of 1 minus x to the power 1/5 squared times by 1/5 x to the power minus 4/5. Right. Now, what was u? Well, u is sine inverse of t, and t was x to the 5th. So, I'm going to do, if I rewrite this, this essentially says sine of u, which is sine inverse of t, which was x to the power 1/5. Close that, and then close that, to the power 4. And I'm just going to put this in the denominator, square root of 1 minus, and then that squared power to the power, so you times the powers, that gives you 2/5 times by 1/5 x to the power minus 4/5, so that can go to the bottom, x to the power 4/5. And look what happens here if I do that. Sine of sine inverse of x to 1/5, well, that's just going to give you x to 1/5. The signs are going to cancel. And that's to the power 4, which is going to give me x to the 4/5. And I just wrote an x to the 4/5 in the denominator. So that's going to cancel. And so we can say this is going to cancel with this. And so I'm just left with 32 on the top. And at the bottom, I've got 5 square root of 1 minus x to the power 2/5. And hey presto, that's exactly what they were asking for. So that's good. Now, the last part said, the diagram shows that curve. Okay, notice that that is almost the same as the derivative earlier. And if we've got a shaded region, it's probably going to ask us to integrate the asymptote x equal. The region is the unbounded region between that curve. Okay, you are given that the area is finite, find the exact area. So they want us to integrate. And it's tending towards an asymptote, so we're going to have to use limit here. So it's going to be the lim of k as k goes to 1, because there's an asymptote there, and it's going to be of the function which so happens to be closely related to the derivative I found at the start, in part B. Square root dx. And yeah, well, if I go back to part B and replace my 1/1 minus x to the power 4/5 square rooted, I'm going to get lim as k approaches 1 of k 0 5/32 f dash of x with respect to x. And now, if I integrate that, that's just going to give me lim as k approaches 1, 5/32. And then when I integrate f dash of x, I'm just going to get f of x. And the limits are k and 0. And now let's work this out. Lim as k approaches 1. So 5/32, I should probably just take the 5/32 out. 5/32 of f of k minus f of 0. Well, f of 0, if I just plug in 0 into my function, that's just going to give me x is 0, sine inverse of 0 is going to be 0, so all of these are going to be 0, and so I'm going to be signing 0, which is 0. And so f of k is going to be sine 4 sine inverse of k to the 5th minus 8 sine 2 sine inverse of k to the 5th plus 12 sine inverse of k to the 5th. And then we're trying to work out this as k goes to 1. Well, as k goes to 1, we're going to do sine inverse of 1 and sine inverse of k to the 5th as k approaches 1. The limit of this is essentially going to be sine inverse of 1, which is pi by 2. And so if I sub in pi by 2, I'm going to get f of k as equal to sine of 4 of pi by 2 minus 8 sine 2 of pi by 2 plus 12 of pi by 2. And that's going to give me sine of 2 pi, which is 0, minus 8 sine of pi, which is 0, plus 6 pi. So the limit as k approaches 1 is going to be 6 pi. And so I've got to do 5/32 times by 6 pi. Remember, sine of 0 was 0. And so that's going to give me 15/16 pi.